Think a bond with a higher ionic character must be stronger. Think again. Many assume that a bond with a higher ionic character automatically implies a stronger ionic bond. This misconception stems from oversimplified definitions in textbooks, and the difference between the two is not often discussed. In fact, understanding this difference is the key to acing questions on bond polarity, melting point, lattice enthalpy, and more. And if a multiple choice question asks you to pick the compound with the greatest ionic character, but you pick the compound with the strongest ionic bond, you may have picked the wrong answer. So let's clear this confusion once and for all. Before we understand what ionic character is, we need to know what a covalent bond is. A covalent bond is formed by the sharing of electrons between two atoms. Every atom has its own ability to attract the shared pair of electrons, which is known as its electronegativity. If both atoms have equal electronegativities, they have the same ability to pull the shared pair of electrons towards themselves, so the electron pair stays in the middle, and the bond is purely covalent, or there is no polarity in the bond. But suppose the green atom is more electronegative, it's more electron hungry, and the white atom is less electronegative and it has a lesser ability to hold on to its electrons. The electron pair gets shifted and moves closer to the more electronegative atom. That way, the more electronegative atom gets a partial negative charge and the less electronegative atom gets a partial positive charge because it has lost its share of electrons. If the difference in electronegativity is greater than 1.8, then the more electronegative atom gets the full share of that electron pair and it becomes a negatively charged ion because it has got one extra electron. And the other atom becomes a +1 ion. The attraction between a positive and a negative ion is called an ionic bond, and so now the compound is an ionic compound. So we can consider an ionic compound to be an extreme case of polar covalent bond. Think of electronegativity difference and polarity as a game of tug of war. If there isn't much difference between electronegativities of the two atoms, or the difference is between 0 to 0.4, the teams are equally strong and there is no net displacement of the rope. If there's sufficient difference in electronegativities between the two teams, the stronger team will take a little more share of the rope. If one of the team is much more stronger, or the difference in electronegativity is greater than 1.8, the rope shifts completely to the more stronger team. Electronegativity difference is the key indicator to ionic character. Greater the difference between electronegativities, greater the ionic character of the bond and less covalent character. Whereas if the electronegativity difference is lesser, more covalent character and less ionic character. From this we understand that bonds always fall on a spectrum. There is always some percentage covalent character even for the most ionic bonds and some ionic character to covalent bonds. It's more like human character. Nobody is 100% good or 100% bad. We all have some shades of gray. Next, let's understand what determines ionic bond strength. We have understood how ions are formed. The attraction between the positive and negative charged ions is called the ionic bond. Coulomb's law explains the force of attraction between positive and negative charged ions. According to Coulomb's law, greater the magnitude of charges on the ion and smaller the distance between them, or smaller ion size, greater the strength of the ionic bond. Positive and negative ions do not exist in isolation. A positive ion exerts its positive field all around it, and a negative charged ion exerts its negative field all around it. Hence, each positive ion will attract other negative charged ions, and each negative ions would attract other positive ions, thus forming an orderly repeated arrangement called an ionic lattice. The energy needed to break all these ionic bonds so the ions separate into the gaseous state is known as the lattice enthalpy, or lattice energy. Stronger ionic bonds would mean higher lattice enthalpy, Stronger ionic bond also mean greater energy required to break all these ionic bonds so the ions go into the liquid state. And stronger ionic bond also means greater energy to separate the ions in the liquid state so that they pass on to the gaseous state. Ionic character versus covalent character is based on the difference in electronegativities and it measures how polar a bond is. Ionic bond strength measures how strongly a positive and negative ions are attracted to each other, and that depends on the magnitude of their charges and the distance between them. Once you separate these two ideas, you'll understand how to answer questions that ask you to compare properties from melting points to lattice enthalpies. Here's a myth-busting example. The difference between electronegativities in NaCl and MgO are both 2.2, meaning they have high ionic character, and because it's above 1.8, they are ionic compounds. But sodium chloride has a melting point of 801 degrees Celsius, whereas MgO has a very high melting point of 2852 degrees Celsius. This high difference in melting point is because of the high ionic bond strength in MgO due to the higher ion charge and smaller ion radius in MgO compared to NaCl. Now you have concept clarity. Just because a bond is more ionic doesn't mean it's stronger. Thank you for joining me on Concept Clarity series, and if you found this video useful, share it with your study group. Let me know in the comments which concept you'd like me to clarify in my next video.